Hi, today we're going to talk about SSH tunneling. The presentation is made by Juan Hurtado and Ilya Shapovalov. So first, let's talk about what is SSH tunneling. SSH tunneling or secure shell tunneling is a method of securely transmitting data between two devices using SSH protocol. It establishes a secure encrypted connection between a local and a remote computer, allowing traffic to be sent through an encrypted tunnel. Now let's look at its main use cases. First, it's secure remote access. SSH tunneling is commonly used to secure remote access to servers and other network resources. It allows users to securely connect to a remote server over an encrypted channel. Then, it's also used to bypass firewalls. It can be employed to bypass firewalls and access resources that might be restricted or blocked by network policies. SSH can act as a secure conduit for other protocols as well. It is also used for encrypting communication. Tunneling encrypts communication between the client and the server, ensuring that sensitive data, such as passwords or confidential information, is protected from potential eavesdropping. Now let's look at risks and advantages. The advantages of SSH tunneling is, first of all, security. It provides a high level of security by encrypting data and protecting it from interception. Also, versatility is a strong point. It supports various applications and protocols, making it a versatile solution for securing different types of communication. It is also easy to use. Configuring and using SSH tunnels is relatively straightforward, especially with the widespread availability of SSH clients. And some of the risks that are possible is, first of all, misconfiguration, as incorrectly configured tunnels can pose security risks, potentially exposing sensitive data. Also, some security concerns is if the connection is not secure between the client and server, your traffic is vulnerable to interception and potentially manipulation. And the network overhead from the encryption process adds some overhead, which might impact performance in high traffic scenarios. Now let's quickly look at the configuration steps of an SSH tunnel. First, we gotta initiate SSH connection by opening a terminal and initiating an SSH connection to the remote server using the SSH command. My partner will show you in detail how to do that. Then we gotta enable remote port forwarding by using the L command, the L option to enable remote port forwarding, specifying the local and remote ports. Next, we have to capture packets locally. For example, on our local machine, by using a packet capture tool like Wireshark to capture packets on the specified local port. And then last steps, we can analyze captured data locally as the traffic is securely tunneled through the SSH connection to the remote server.
Hello everyone, I will be demonstrating a live Netcat session between two host computers, and I will be showing the differences when using a Netcat conversation with tunneling and without tunneling. On the right hand side of the screen, I am setting up a virtual machine as the listening or server host, and I am configuring it to listen to incoming traffic through port 2929. At the same time, I am enabling instructions to be executed on command prompt. On the left hand side of the screen, I have a client host, which is my physical computer, and I am writing instructions to establish a connection with my virtual machine with IP address 192.168.3.34 on port 2929. As you can see, I have created a TXT file on the server host with message, "This is a test." And what I want to show you now, it's the TCP payload details that can be retrieved when tunneling is not being used in a communication session. So as mentioned before, here's the payload detail that is clearly visible to anyone on port 2929. There is no encryption whatsoever. So now what I would like to do next is to end this Netcat session and instead establish a tunneled connection by using SSH protocol. So next, I am going to connect the SSH server that was set up prior to this demonstration on my server machine, and I am specifying the server's name along with its IP address. By default, the connection is established using port 2022 because that was the port that was assigned when configuring the SSH server. So now I will be doing the same exercise I did previously with the communication session without tunneling, except this time it will take place through a SSH connection, and I am going to write "This is another test" as the message. So let's go back to Wireshark to analyze the TCP package by filtering traffic through port 2022. As you can see, the TCP payload information appears to be encrypted, as SSH protocol uses a strong symmetric encryption and hashing algorithms to ensure the privacy and integrity of data that is exchanged between the client and the server.